Okay, so this mini lecture is an example of what information can we get from a velocity versus time graph. What does it tell us about an object's motion? So here we have a velocity versus time graph on the screen, and we're going to remember that our axes are 0 velocity value, that above the axis the object is moving in the positive direction, and below the axis the object is moving in the negative direction. All right, so what do we know from the beginning? If this is our whole motion we're trying to describe, could we write a motion story about this object's behavior? Well, we first have to think about other parts of a motion story. Can I say anything about where the object is located in space when looking at a velocity time graph? It turns out I can't. This is just telling us how fast the object is moving. The object could be doing this motion in Timbuktu, it could be doing this motion in Menominee, it could be doing this motion in Canada. We have no idea where the motion is happening, we just can describe what the motion looks like. So that's one very important feature to think about. Velocity versus time graphs give us no information about where an object is located and only information about what an object is doing. Okay, so what is the object doing during this time? At the beginning, what do we notice? We notice the value of the velocity is above the origin, above the horizontal meridian here, this axis, and so it must be moving to the right. So we know the object is moving to the right. We'll use right and left as our axes. Now it's moving to the right at a certain value, so it's moving to the right at some value, and it does that for a while. So during this phase, we have constant rightward motion, constant motion to the right. It's staying at a steady rate and it's moving to the right. Once we hit this area, what's happening? Well, is the object moving to the left or is it moving to the right? It's still above the axes, so it's still moving to the right. Anything up here is rightward positive velocities. So we know we're moving to the right. But how is that motion changing? Well, it starts off with big numbers, and those numbers get smaller and smaller and smaller as time moves forward. So if the velocity is getting smaller and smaller and smaller, we're moving to the right and we're slowing down. And because it's a straight line, we're actually slowing down at a constant rate. And like I told you in our discussions of acceleration, we're only going to look at constant slowings and speedings ups. Perfect. Well, what does it do here? At this point, the object is actually at 0 velocity, and it's staying at 0 velocity as time goes on. If it's not having any velocity value, we can say that at this point, the object is standing still. So the object is standing still. It's at 0 velocity. Then what does it start to do? Well, it starts to increase the value of the velocity. So the object is starting to move. And as that time goes on, that value is getting bigger and bigger and bigger, so we know the object is getting faster and faster and faster. Is it moving to the right or to the left? Well, it's above the axis, so it must be moving to the right. So during this phase, we're moving to the right. We're getting faster and faster, so we are speeding up. All right. What happens at this point when that line flattens out? Well, that line is representing velocity, and it's above the axis, so it's representing a positive velocity. And it has a value that is not changing as time goes on. So here is a case of still moving right at a constant velocity. All right, so those first 5 make sure you're comfortable with, because the next phase is a little trickier. Okay, so what happens at this point? Well, the object is still above the axis, or the line is still above the axis, so it's still positive. We're still moving to the right here. And what are we doing as we move to the right? Well, our numbers for velocity are getting smaller and smaller and smaller, so we have to be slowing down. Then we hit this special little point right here, which we all like to think is kind of more special than it is. And immediately after we hit that 0 value, we start below the axis. Now if we're below the axes, we're moving left. And as we move left, our numbers are getting bigger and bigger and bigger and bigger, so we are speeding up. As we move left, we continue to get bigger and bigger, faster and faster, and we're speeding up. Until we hit this point where we're below the axes, we're moving to the left, and we're at a steady rate. As time goes on, our velocity does not change. So what happened at this special little point? Well, we were moving right, then we started moving left. So at this passing through of 0, we are passing through 0. I'm not stopping. I don't stop. I pass through 0, and I turn around. So when the velocity versus time graph crosses the axes, that's a turning around point. We're turning around, passing through 0 and moving from one direction, now moving to the other direction. So thinking about how to interpret that velocity versus time graph, lots of details in here. Make sure you understand how that stuff looks. Good job.